Again, coming back to the section of the basic monochromatic television system receiver, we have to use that. I have told you the previous video that we have to use the double receiver sections because we have to synthesize two things. First of all, the audio section, and second is the video section. So video detector will take from the common IF amplifier, it will take the video section out of it, so audio section out of it, and send it to the sound IF amplifier. And here is the sound modulator. Now I would ask you that what kind of modulation should be used here in that section. That will be frequency modulation as a demodulator section. Frequency demodulator, because frequency demodulation has been used in the transmitter section. Let us go through to the transmitter section. Now you can see there is in transmitter section there is FM modulating amplifier is used as an audio amplifier, audio modulation technique. So the same modulation technique will be used here too. Then the audio amplifier will amplify the audio and we will listen it from the loudspeaker. That is a very simple task and simple circuitry in that factor, as well as the radio receivers. But there are double-sided radio receiver has been used, and both radio receivers has been conducted because to extract video and audio. After tuner tunes it, go to the common IF amplifier and then go to the video detector. After detecting the video signal, that will go through to the video amplifier section to make it synchronization. There are also a closed loop section. Kindly just watch the direction of the scanning synchronization section. You can see the scanning and synchronization circuit is one-sided here in the receiver section. Why it is gone through the one-sided signal? Because the video detector has the directions that which object moves in what direction and what kind of movement has been going on to the signal. So there should have to be one-sided signal that will go through to the scanning and synchronization circuit to scan the picture on the picture tube. That is the picture tube. We could see the picture through the picture tube. Now we can see that the picture through the picture tube. But the total scanning will have to be operated by the video detector, because video detector has some of the information that which side the scan should have to be gone through and which colors that should have to be shown to you. And if that is not a matter of color, that how the synchronization, how the scanning should have to be made through the video amplifier, the video signals. That is the main thing. So that is one-sided arrow sign that has been given here. That means that it's a one-sided signal that can be gone through to it. Just go through to the transmitter section. Here we can see that is the scanning and synchronization circuit are usually go through to the both-sided signal. Why that is go through to the both-sided signal? Because each and every time the amplitude modulation amplifier has to adjust the scanning and synchronization, that means the signals, that means the information that has been coming through to the camera tube and then go through to the combining circuits and all. So in that section we need this kind of thing, this kind of scanning and synchronization with the two-sided sections. But on the matter of fact, we have seen here, on the matter of fact, that is the scanning and synchronizing circuit in the both sides. Now just go through to the other part, that's the receiver section. Now that is a very much important thing, that it has go through to the single-sided way to have the better scanning results on that factor, so that we can get this kind of thing. Now here you can see that that is the thing that has been gone through to it. Now we should have to have a clear knowledge, some definitions of our monochromatic television. Now coming back to the section of the human eye contains, that how that the scanning will go through to it, and some we have to know some basic parts through it too. Now just look at the texts from here, from the book of George Kennedy. You can see there the human eye contains many millions of photosensitive elements in our retina to extract such kind of nerve fibers, to such kind of signals from the pictures out of it. Now you can see there are TV receivers, some 1000 1,50,000 effective elements are displayed in each scene. The use of that number of channels is out of the question. A single channel is used instead, each element being scanned in succession to convey the total information. Now, coming to the point, that some basic definitions are go to that. This is done at such a high rate that the eye sees the whole scene without being aware of the scanning motion. That means the eye sees this without the scanning motion. We can see that in the pixels that will extract the things. So in our television, the scanning was made so fast that our eyes are got fooled. The eye is fooled into seeing continuous motion through the property known as persistence of vision. We have a persistence of vision of 0.1 second. That means if we cross this, if we have a lesser time to just put the images part by part, we can't understand the changes, the throughout changes, but the change has been made. It's a persistence of seeing. Okay, and you can see here there are 30 pictures or frames as they are called per second in the US television system. The number of frames are related to the 60 Hz frequency of the AC voltage system. They use the 60 Hz frequency to make the eye believe that it sees continuous motion. So we have to make it quite fast. The films are run at 24 frames per second. 24 frames per second to achieve this goal, that one could see a continuous change in the motion, but that is a scanned pictures, still pictures are running through to it. While the perception of smooth motion still results, the flicker due to the right cutoff between the frames would be obvious and distracting. That is known as the flicker. That is known as the flicker. That means that is the light cutoff between the frames that would be obvious and distracting. In motion pictures, this is circumvented by passing the shutter across the lens in a second time. Shutter means we have just open and close our eyes, and that has been light of occurs at the 48 times per second. Per second we have flickering our eyelids 48 times. This is too fast for the eye to notice the flicker. Flicker means just means just stop and show, stop and show, stop and show. But the flickering is so fast, that means 48 times per second, that our eye couldn't understand it. The same effect could obtain running a film with 48 frames per second. Same effect could go through, but this would result in all films being twice as long as they need to be. That means it should have to be twice as long. So that is a very basic things. And while scanning, that is a horizontal scanning and that is a vertical scanning. So we have to know it very well. One is fast and horizontal. Horizontal scanning is fast. That means the horizontal scanning is just like that. If it is a television screen, that is a horizontal scanning, go through to that zigzag way, and the vertical scanning will go through to the up and down way, and that will have to be. And other vertical scanning is very slow, and being 262.5 times slower than the horizontal motion. The beam gradually moves and a complete frame is covered 525 horizontal lines, which are traced out of 30 times per second. However, each scene was shown traced thus from the top to bottom, left to right. So that's all for now, and that is known as the interlace